Hi there. I'm sure you know this formula is very useful when it comes to finding the number of moles, mass, and sometimes the molar mass. You should also know that this formula is very useful if we're finding the number of moles of gases and sometimes even volume of gases. Lastly, you should know that this formula is also very useful when we are finding concentration involving the moles and volume. But how can we apply the mole concept? This is the online school. In this video, you and I are going to be looking at application of the mole concept. We're going to do this in a systematic way. Firstly, we're going to look at the mole concept formulas that you need to know for you to be able to apply the mole concept. Then we're going to look at the concept of mole ratios, which is very important when we start applying the mole concept. Thereafter, we'll have some bonus tips. Make sure you watch this video till the end to get the maximum value out of it. There are mainly three formulas. The first one is this one, which involves mass. It comes from this definition here. The formula is N is equal to mass of a substance. Sometimes it is just referred to as physical mass divided by the molar mass. The molar mass is the mass of a substance equal to 1 mole. In abbreviation, this is N is equal to M over mR. There are two things that you should note. If the number of moles being calculated is for a molecule, the molar mass is the same as the relative molecular mass. While if the number of moles being calculated is for an atom, the molecular mass is the same as the relative atomic mass. If you want to know more about this, check the video about how to use mole concept formulas. The second formula is about gases. N is equal to the volume of a gas divided by the molar volume. Molar volume changes depending on the conditions, and in this small information tip here, that information has been given to you. In abbreviation, this formula is N is equal to V over mV. You should also note two things here. If a reaction was carried out in laboratory, you need to use room temperature and pressure because a laboratory is just a room. Then you only use the standard temperature and pressure if the question tells you to do so. If it's not stated in your question, it's usually RTP. The third formula involves concentration. And by the definition of concentration is where this formula comes from. C is equal to the moles of the solute divided by the volume of the solution. In abbreviation, we've got C is equal to N over V. But you should note that there are two kinds of concentration. This concentration here that we've looked at, C is equal to N over V, is molar concentration because we're using the number of moles. We also have another concentration, C is equal to mass of a solute divided by the volume of the solution. This one is mass concentration. As you can see, we have mass in our numerator. Therefore, this one will be C is equal to M over V. Now, two things worth noting also is that you can convert between mass concentration and molar concentration. If you want to know that, check the video about how to use mole concept formulas. Next, you should also always remember that molar concentration can also be referred to as molarity. Now, with these three formulas, you can now be able to easily apply the mole concept. But before you get applying the mole concept, you need to know the concept of mole ratios. By definition, this is just a ratio between two substances that shows proportions by which they react or get produced. That's the definition of a mole ratio. So if you know how to form ratios, you're home and dry. And if you know a bit about proportion, what a proportion is, you can easily work with mole ratios. It's worth noting that mole ratios just come from a balanced chemical equation. In actual sense, we just get those numbers in front of the reactants or the products. In these examples, we're going to look at forming mole ratios from two chemical equations. In the first chemical equation, we have nitrogen reacting with hydrogen and producing ammonia. The numbers we'll be using are these numbers in front here, like 3, 2, 3, 2, and 3. Let's start with this first example. We're going to get three mole ratios from this chemical equation. The mole ratio for nitrogen to hydrogen, As you can see, nitrogen here has no number in front of it, so we take it as 1 when we don't see a number. It's like in algebra, when you have x, you know that in front of that x there's 1, but we cannot say 1x. Then they've told us to make a mole ratio with hydrogen. Hydrogen is this one here. So you should know your chemical formulas by now. If you don't know them, you can check out the video about how to write chemical formulas. The mole ratio for nitrogen to hydrogen is 1 to 3. Now let's go to the mole ratio for nitrogen to ammonia. You can see this process is not very difficult. Nitrogen is 1, ammonia is 2, so the mole ratio will be 1 to 2. For hydrogen to ammonia, we have a 3 here, and ammonia has got a 2. So we have a 3 to 2 mole ratio. Let's get to the second question and get to know how to write even more mole ratios. We have carbon monoxide to iron. Carbon monoxide is this one here. We've got a 3 in front of it. Iron is this one here. This one is not iron, this is iron 3 oxide. So our mole ratio for this one is 3 to 2. For carbon monoxide to carbon dioxide, this is carbon monoxide and this is carbon dioxide. We have a 3 and another 3. So our mole ratio is 3 to 3. Now, it's worth noting that when we have a mole ratio like this, where the first number is the same as the second number, this mole ratio is taken to be 1 to 1. That applies to even other mole ratios. If you have a mole ratio that can be simplified, simplify that mole ratio and use the simplified version. Now, let's find the mole ratio for iron to carbon dioxide. Iron is this, carbon dioxide is this one. So you can see there's a 2 here and there's a 3. So it will be 2 to 3. This is basically how mole ratios are formed, and this is what we mean when we're talking about mole ratios. Let's look at another example where we're using the chemical equation below to answer the questions A and B that will follow. Here we've got another chemical equation. As you can see, we've got ammonia, oxygen, producing nitrogen, and water. We've been asked to find how many moles of water are produced when 5 moles of oxygen are used. Right from the start, if you don't know about proportion and mole ratios, this question might be very difficult. But the concept of mole ratios can be thought of you making some juice. Obviously, you have the juice and you have the water. When you get a lot of juice, you need a lot of water. But there's a fixed amount of water that you need for some juice, right? Yes, so mole ratios are just that fixed amount of quantity that you need for a certain substance to a certain substance. So when they tell us to find the number of moles of water produced when 5 moles of oxygen are used, this chemical equation here is going to give us the fixed proportions of water that is produced with a certain amount of oxygen. When we check here, we're going to look at the mole ratio between oxygen and water. One thing I encourage you to do is that start with the side where you have more information. So you can see we have 5 moles of oxygen that will be used to form some water, meaning oxygen will be on my left, then the water will be on my right. But before that, we need to find the mole ratio of oxygen to water in the standard form. That will be 3 to 6. Remember, if we have a number that can go into both of these, we are just going to divide by that number and get this ratio simplified. You can see 3 can go into both numbers, therefore our simplified ratio will be 1 to 2. Meaning, if we have 1 mole of oxygen, we will need 2 moles of water. Now, this 1 to 2 is a very important ratio that will enable us to find the moles of water that will be produced when we have 5 moles of oxygen. Now, it's very important that above this, maybe you indicate which side is oxygen and which side is water so that you don't get the ratios confused. So in this case, we're starting with 5, so I'm going to put a 5 here and an X on the side of water because I don't know the amount of water that will be produced if I use 5 moles of oxygen. Now, from using proportion in mathematics, you can remember that we cross multiply after we have two similar ratios that are showing the same proportion. When we cross multiply, we have two products, 1 times X and 5 times 2. These will be equated to each other and then we're going to find the equation that is produced. So we're going to have X this side and 10. Very simple. Now this 10 is for what? The moles of water. Very simple, as you can see. This process will be very important when we begin applying the mole concept. So make sure you understand it totally. In B, we've been asked that if 7.5 moles of water is produced, how many moles of ammonia were reacted with oxygen? As you can get from the wording of the question, we're finding the moles of ammonia. How many moles of ammonia were reacted with oxygen? What we've been given here is the moles of water. So when making our ratios, we want to make the water appear first in the ratio, then the ammonia second. So water is here, it's got 6, ammonia has got 4. So our ratio will be 6 to 4. Now remember, this can be reduced because 2 can go into both numbers. Here we have a 2 into 6, which gives us a 3, 2 into 4, which gives us a 2, meaning this ratio can be simplified to 3 to 2. Now, I'm sure now we're getting comfortable. We have 7.5 moles of water, so we're putting a 7.5 here and an X for the ammonia that we want to find. If 7.5 moles of water is what is produced, then how many moles of ammonia were reacted with oxygen? It's the ammonia that we want to find. Again, we cross multiply here just like we did, get the two products, 7.5 times 2 and the 3 multiplied by X. Here we have 3x, of course, and here we're going to have 15. 3x is equal to 15 is our equation. Now we need to get rid of the 3 on our left side. This 3 is multiplied by the x, so we're going to carry out the opposite of multiplication, which is division. We're going to divide both sides by 3. Here the 3 and the 3 will cancel, and x will be equal to 15 divided by 3. If you know your multiples, that should give you 5. These two examples must be understood because this is the basis of application of the mole concept.